Our topic for today is about radical equations. Radical equation is when the variable in an equation is in a square root, cube root, and so on. That is, it occurs in a radical. The thing that you should remember is that the variable is in or under a radical sign, not the constant, not the coefficient, but only the variable. So for this, we are going to use the power rule, which says that if in an equation a equals b is true, then a to the power n equals b to the power n is true for all natural numbers. So for example, we have here the square root of x equals 5. Here we have the index here. A number that is written here indicates the root that we are going to extract. So here we cannot see index, so this is considered to be 2 or square root. So we are going to raise this one to squared, both sides of the equation, to take out the square root, the radical sign. So, and this is equals to x equals 25. So square root of 25 is 5. Another example is 2. The cube root of x equals 4. Here we have 2 as coefficient of cube root of x. So to simplify this one, we are going to divide the right side of the equation by 2, or transpose 2 to the other side of the equation, to the right side of the equation. We have here 4 over 2. So the cube root of x equals 4 divided by 2, and this is equals to 2. So since this is a cube root, we are going to raise both sides of the equation by 3. So we have a cube root of x to the cube equals 2 cubed. So this is equals to x equals to 8. For example, we have here the square root of 3x plus 4 equals 5. Since we have a square root, so in order to remove the radical sign, we are going to raise this to square both sides of the equation. So square root of 3x plus 4 squared equals 5 squared, and the radical is removed, and 5 squared is 25. So we have 3x plus 4 equals 25. Then move 4 to the right side of the equation. We have 3x equals 25 minus 4. 25 minus 4 is 21. So we have x equals 21 divided by 3. And this is equals to x equals 7. So that's the solution to the problem. To check, we have the square root of 3x plus 4 equals 5. So substitute 7 to x. We have the square root of 3 times 7 plus 4 equals 5, and this is equals to 21 plus 4 equals 5. 25, square root of 25 equals 5, and 5 equals 5. Another example we have here, x minus 3 times the square root of x plus 2 equals 0. Here we are going to transpose 3 square root of x to the right side of the equation. So we have here x plus 2 equals 3 square root of x. Then square both sides of the equation. We have here x plus 2 squared equals 3 square root of x squared. Then we have binomial squaring. We have x squared plus 4x plus 4 equals 9x, because 3 squared is 9 and square root of x squared is x. So we have to transpose 9x to the left side of the equation. So we have x squared plus 4x minus 9x plus 4 equals 0. And 4 and minus 9x is negative 5. So we have here x squared minus 5x plus 4 equals 0. And we can solve for x using factoring. So we have here x minus 1 times x minus 4 equals 0. And we have x sub 1 is x minus x sub 1 minus 1 equals 0. So x sub 1, and the other value of x is x sub 2 minus 4 equals 0. So first solve for x sub 1. We have x sub 1 equals 1 and x sub 2 is equals to 4. So we can also use another method for this one. We have here x minus 3 square root of x plus 2 equals 0. Let a equals square root of x. So a squared is equals to x. Substitute this one. So we have a squared minus 3a plus 2 equals 0. We can now use factoring here. We can factor that a minus 1 times a minus 2 equals 0. So a sub 1 is sub 1 minus 1 equals 0. First value of a. Then we have the second value of a sub 2 minus 2 equals 0. So a sub 1 equals 1. And a sub 2 equals 2. Then go back to the a squared equals x. So we have here x sub 1 is equals to a sub 1 squared, which is equals to a sub 1 equals 1 squared, and 1 squared is 1, so x sub 1 equals 1. And the other value of x is x sub 2 equals a sub 2 squared. So we have x sub 2 equals 2 squared, x sub 2 equals 4. That's the other method of solving this one. We substitute the square root of x, a, and a squared equals x. From that, we can use the factoring of a quadratic equation.